Okay, well, we now need to calculate volume. All right, so the way we're going to do that, we have everything in centimeters. All we have to do is we're going to calculate volume of the coins. Now remember, we're assuming that the coins are pretty roughly cylinders. As one of the students in one of the classes pointed out, because they're carved and they have nooks and crannies, they're not perfect cylinders. Those nooks and crannies means they're probably going to wind up being a little bit less volume than the actual weight is going to be indicated. But we're going to assume that they're perfect cylinders. So how do you do that? Well, if you actually go over here, I actually Googled this. Volume equals pi times radius squared times height. Now, so how are we going to do that? Well, first we've got to find pi, and pi is 3.141. I'm just going to be real lazy and copy that. So I'm going to go back to my spreadsheet, which is this one here, and I'm going to go equals pi, all right, that number, times, I'm actually going to type that in because 3.141, 3.141 times the radius squared. Now, how are you going to do that? Well, I'm actually going to cheat. I'm going to go times the radius times the radius, and I'm going to select it again. And I just realized I want this to be times. Okay. Then I'm going to close that, so that's radius squared, radius twice, times, let's go back to my formula again, pi times radius times radius times height. So I'm just going to go back to there, and now all I have to do with my formula is go times the height, which is the thickness in centimeters. Okay, so if we add all of that up, we should get a volume of that. All right, and that looks pretty good. All right, and so let's just check the formula again. Pi, which is 3.141, times r squared. Radius is radius is this number, the radius in centimeters, times the height, which is that. All right, and I'm just going to move my mouse over to the lower right-hand corner, and I'm going to do a drag fill. I'm going to pull that all the way down, and that's going to give me the volume of all these guys. And now all I have to do, if I want to calculate density, and this I hope you guys all know, D-E-N-S-I-T-Y. All I have to do is I'm going to take density, I'm going to take the weight in grams, which is this column here, and I'm going to divide it by this column, and that'll tell me the density of each one of these coins. So it's equals mass, or weight, divided by volume. Boom, there you go. And that's the density of the coins in grams per cubic centimeter. There you go. All right, so that's how you calculate density of the coins. All right, and you notice we got some odd numbers here. Some of these look a little off. All right. So let's see what we can get done with that now. All right, so we now know what the coin's density. So the 1922 silver dollar should have a density of 2.9 times 10 to the 2.9 grams per cubic centimeter.